Most definitely. But the only thing is I have a better resistance because I've seen, like, I've exposed myself to more of the germs because of all of you. So, one of the issues, as we're waiting for a couple people to straggle in, one of the issues with the like, clean revolution and hand sanitizer is now kids are living their childhood too clean, not enough germs, and then they get into, like, middle school and high school and they're sick all of the time because their body has no resistance built up. Being exposed to germs is not a bad thing. You need that when you're young so your body builds up resistance. So picking up where we left off yesterday, we can classify angles as acute, right, and obtuse, and then we get some other angle pair classifications that we'll get into. But let's talk about the 3 angles that are here. And you might be like, Hudson forgot how to count. There are 3 angles here. We have angle. Who can give me one of them? Andrew?
Well, you have the acute.
So name it. How do you name the acute one? The 3-point notation we talked about yesterday. So we talked yesterday about how we name angles and the order that it has to be in. Do you remember?
Okay, so the smaller one, the smaller angle is the acute one.
How do we name it? How would we call it? We use the letters that make it up.
Oh, wait. AOB is an acute angle.
Yes. Why'd you say AOB?
Because O is the vertex.
Yeah, the vertex has to go in the middle of your angle name. So then when I go to name the obtuse angle, that's funny, you were actually on top of the stack, Andrew. Maylee, can you see an obtuse angle here and name it? So how do I name it using the 3 points? I'd say angle B. What's the vertex? What's in the middle? O. And then, yeah, it ends at C. So angle BOC is obtuse. Who's got their brain really turned on today and they know my 3rd angle? Shane? Angle AOC is what kind of angle? Is straight. So here's the thing that throws a lot of people off. And this is, if you've ever seen on the internet, they're like, how many boxes do you see? Most people get this wrong. There are boxes inside of boxes or boxes around boxes. There are angles inside of other angles or bigger angles made of combining smaller angles. So we've got little angle, kind of bigger angle, both angles combined is how we get our 3 angles there. Any questions on how we do that? Now we're going to tie the algebra into the geometry. So you see a flag, and you know that the flagpole is supposed to be perpendicular with the ground. Perpendicular means they meet at a 90-degree angle. So we see angle 1 here is perpendicular, it's a right angle, and then we get told it's 3x minus 15. So go ahead and write the measure of angle 1 and try to leave yourself some space here. Is 3x minus 15. But we see that it's equal to, what's this box tell me? How many degrees? 90, right? And if we are asked to solve for what the value of x is, then Casey, do you know what I would do first? Trying to isolate this x value. We want to add 15. This is just our equation solving. Work PEMDAS backwards. Add 15 on both sides. So whatever 3 times that x value is, comes out to be 105. And then to finish isolating my x, Abby, we want to... Yep, we divide by 3 on both sides. And we get that x is equal to 35. So try this on your own when you're told that this actually measures 60 degrees. Now, some of us can actually reason through this stuff in our head because you've done enough of the equation solving that you're good at it now. Not most of us. Most of us have to write this stuff down. Otherwise, we're going to make mistakes. Yeah, so if you did the homework, you've already seen problems like this. So, Izzy, kind of volunteered yourself there. If you've already done the homework, what do I set up here? So sorry, what? You did it in your head. So what'd you do in your head then to solve this? What'd you get first of all? So what we should get is x is 45. But we want to talk about how do we get there. We know that this angle measures 60 degrees, but they tell us it's this expression, 2x minus 30. So we start by doing what with those values? If they both represent the size of the angle, Walker? So, yeah, first we really set them equal. So if we want to talk about what we have to do, we set these equal because they both represent the same thing. They represent that angle. Now, like Anthony said, we add 30 to both sides, and we get 90. And then what do you do, Anthony? We divide by 2. That is how we get our x to be 45. Any questions on this? This work, even the algebraic work in here, should be easier than Chapter 9. If you've survived Chapter 9 and you're done with that practice, you should be able to kind of have a big exhale of like, okay, we made it. And that's also why we always say that quarter 3 is really tough. I don't know what's going on with my board, guys. Yeah, but I just did. So go ahead and flip to your 10-2 notes. So check out this beginning problem while I calibrate. If BAC measures 100, I want to know everything that we can figure out about the other angles. And actually, if you did the homework, you probably saw a question very similar to this one. So this whole thing is 100. That whole thing is 100. So Julia, if that whole big angle is 100, what's something else that we know?
That both of those two other ones together, the two other angles together equal 100.
Yeah, so we could write that angle, and they already kind of told you something. I don't know where is a safe place that I can write. One of my points has gone bad, is what's happened. So on your paper, you want to write that angle BAD, angle bad, and angle DAC, angle DAC, add together to make 100. Let's try this again. Angle BAD plus angle DAC. Why am I putting a little arc through my angle symbol? You want to remember? Yeah.
Because, wait, I was going to say, that would be for right angles. I was going to say, because it has a little block.
This indicates that I'm talking about size. I'm not just naming it. I'm talking about the size of it.
Is that DAC?
Yep, bad, DAC. Together, they equal 100 degrees. So, what if, I'll go along with you guys, what if I wanted to know how to find angle DAB? What if we wanted to find angle dab? My math 2 class would be very mad because that's the first time I've ever dabbed.
Wait, I didn't see it.
Yes, sorry.
It's on video.
Maybe if you were awake and paying
The
attention.
video.
No, I didn't want to look.
How could I find this angle? If I know that the two angles together make 100, Hayden? Is it going to be bigger or smaller than 100? Smaller than 100. So I know that I could start with 100. Hey guys, this is like identical to a homework question. So you're probably going to want to have this down or in your knowledge. But it's not 100. It's 100. Take away what? Take away what, Grace? Whatever this unknown angle is. But we don't know what size it is, but we do know its name. It's angle DAC, or CAD. We'll call it CAD since we're switching orders around. So remember, order that I write it doesn't matter. DAC and CAD are the same angle. They both use DAC, CAD. They're the same angle. BAD and DAB, same angle.
It's because A is still.
Yep, A is still your vertex, and it still uses the same endpoint. So, likewise, who can make the connection for how we could solve, sorry, I'm out of space to write, how we could solve for angle CAD if I wanted it. If I was able to solve for angle DAB by doing a subtraction, could I do the same thing for CAD? Izzy?
You do 100 minus that.
Yeah, 100 minus the angle DAB. And that's pretty much what we know about them. One student was trying to argue with me that one of them has to be acute.
What if they're both acute?
So they could both be acute, but if, and somebody tried to argue that this was 90, but it looks more than 90 to me.
It looks like it.
Yeah, it's
looks
more
like
than 90.
95.
So at least one angle would have to be acute. But both of them could be, because we don't know anything about the sizes. If this really is 100 combined, which it's not. If you measured this with a protractor, it's not 100 degrees. But if it was, this would probably have to be like 95 and 5 or something like that. Like, this looks bigger than a right angle, but really, I mean, it's not drawn correctly on here. Which is why we talked about yesterday, do not use the protractor unless you're told to use it. Otherwise, the drawing may not actually be drawn correctly. Questions on this? So, adjacent angles make everything easier to work with. Because adjacent angles let me partner things up, and they let me figure things out based on those partnerships. Now, to be adjacent, and I want to go back to my start slide here, so give me your eyes real quick on the start slide, because this is something that I will readily admit I did not teach very well in the past.
What?
Adjacent angles have to share two things. They have to share a vertex, and they have to share a side. Thank you, Grace. What can't happen, though? That's the tricky part. So, like, I am adjacent to my desk right now. I am right next to it. I'm touching it. I'm like sharing space. I'm adjacent. We use adjacent as like a word just meaning next to. Abby, what can't happen?
Isn't it they can't intersect?
One cannot be inside the other. So if I somehow could climb into my desk.
Good morning, Cassidy Oyer. Please come to the office. Cassidy Oyer to the office, please. Thank you.
I open this drawer and I hop on in. I'm no longer adjacent. I'm inside of it. So notice that that says angle 1 and ADC. ADC is your large angle there. It's the combined angle. Those are not adjacent because one is inside of the other. Notice angles 3 and 4. Well, that's not even close to adjacent because they don't share the same vertex or a shared side. But the big thing is paying attention to one cannot be inside the other.
So AOC is not adjacent to B.
So AOB and COD aren't adjacent because they're not touching. But also, off to the side here, I'd like you to write that angle AOC and angle, what angle is inside of AOC? There's actually two of them. Justin?
What?
Not a hand. CJ? AOB cannot be adjacent because one is inside of the other. They cannot contain each other. So if you can remember that, that's okay. Otherwise, I would notate that. That's where people get screwed up. If one's inside the other, they're not adjacent. And that's tricky because do AOC and AOB share a side? Yeah, they both have AO. Do they share a vertex? Yeah, they both have vertex O. But the problem is, yeah, one angle's inside the other. That's not adjacent. So if you think practically about this, you could be adjacent to your house when you're standing next to it. When you are inside your house, you're not adjacent. You're not next to, you're in. So, I mean, there's a lot of applications we could do. Any questions? So they need same vertex, shared side. Cannot be inside of each other. So on this diagram down here, anyone ever ridden the Beast at Kings Island? Yeah. So the Beast is terrifying because it's all wood. Like, well, there's metal involved, but it's pretty much a all wood roller coaster, and because of that, you feel every little bump. Now, as you're going on the roller coaster, you see trusses and supports that a lot look like this. Because triangles are extremely strong. Engineers a long time ago realized that triangles are the best way to disperse weight. Because when you're riding on the track and your weight's pushing down, these are all connected so that it can actually brace and support the weight. If we just had straight boards and horizontal boards, it would crumble. It would literally compress itself. So triangles are what make our architecture safe. We want to name angles adjacent to the given angles. So take a moment, because then I'm going to use cards and ask you guys, look for possible angles, and there might be more than one adjacent to. So I'll help you with the first one. If I look at angle FAD, start at F, go to A, go to D, that's this angle. I'm trying to find an angle adjacent to it, sharing the same vertex, sharing a side, not inside of each other. Can anyone spot my adjacent angle here? Is he? Yeah. Again, here's our angle DAB, DAB. That is adjacent. Or bad, same angle. If you switch the first and third letters, it does not change your angle. So try B, C, and D. There may be more than one. If there's more than one, go ahead and list every one that you can figure out. Question or answer?
Question.
What's up?
Would BAG count as an adjacent?
Ooh! So, the question you really should be asking is that a different angle? So, thank you very much for asking that. I was about to not... We would have thought about that once we got to a couple different problems. So, this angle... Give me your attention real quick. I'll give you some more time. This angle is our BAD. Or DAB, whichever we care about. But if I go BAD, what if I go BAG? Is that a different angle? No, it's just another way to name it. Because I still use this vertex and these edges. What if I had said angle CAG? Is that a different angle? It's just a different way to name it. So, DAB is the easiest way because they're close, but I could also, the same angles are also BAG or angle CAG or angle CAD, or I think that's all the ways that we can name that. But you don't list these because they're not different angles, they're just different names. So any of those would work on that line. I'll give you another minute or so. I mean, you can identify those again.
Okay, why do you have to switch up the letters?
I'm not saying you have to do this, but I have to see it.
Why do you have to switch up the letters?
The only thing that matters when you name your angle is that the vertex is in the middle.
And the vertex is already in the middle.
Yeah, so here your vertex is G. We start at B and we go to C. So B, G, C. This is our angle in here. So then to find one adjacent to that, you said CBG.
Yeah, but then I realized.
So CGB. But that's the same angle. BGC is this angle right here. So you need adjacent to it. So you need the one next to. So here, let's first draw it. So this is the angle next to it, right? Now we use this side and this side. And we can ask, what points do I use? Well, I start at H, I use vertex G, and then I could go to E, or I could start at H, go G to C. So I could do HGE or HGC. That's up to us. So this is the dangerous thing about writing these things in highlighter. I would be careful. I would like scribble that out so it doesn't confuse you. We'll list them up here in just a second. So keep thinking through the others. Just see if you can reason through the process. It would not hurt to use some highlighters to notate where your angles are. Now, mine are just a little bit big, so it's hard for me to get them in specific locations. But BGC, moving on from my first one, I'm going to erase all things from there. BGC, I start at B, vertex G, go to C, it's right here. So if you've been unable to find that, highlight BGC in a color and make your little arc here. And then you could even notate, I use this edge and this edge to make BGC. To be adjacent to that, I got to share an edge and share a vertex. Hayden? C, G, H will be right here. So we could do angle C, G, H. And that uses that shared edge and then this edge. But there are more options. Anthony? AFG would use this vertex up here and be that angle. AFG would be this right here, because F is your vertex. AGF is this angle right here. It does not share an edge. So I'd erase those if I was you. CJ? What is it? ABG would be this angle right here, and it would not have the same vertex. So you got to be careful that your vertex is that middle point. You have the right points. You don't have them in the right order. You need to use points A, B, and G, but not in this corner. It needs to be in this corner. So to do that, I want this angle. It's sometimes easiest draw the angle first, then name it. That blue angle would be angle BGA or AGB or DGB or BGD, but G has got to be your vertex. So G's got to be in the middle. Questions on that blue angle? So that's could also be angle BGD is just changing point name, or DGB, or AGB. No, you don't have to list all of them. I'm just making sure that you guys understand there's a lot of ways to name the same angle. Questions on naming that blue angle? So we've got a green angle adjacent, a blue angle adjacent. There's still more adjacent to that same start angle. So that I don't confuse anybody, I'm going to actually capture each individual question. I'll do 2 on one slide, 3 on one side, and then 4 on one slide. Okay. No, I can't start down at H. We don't use straight angles as adjacent angles either, if that's what you were trying to do. What if I still use this edge, and I still use that vertex, but I do this angle? BGF is also adjacent. So we are not looking at question C. We're still listing. That black angle, BGF, is also adjacent. Questions. This is weird. What about what? BGH? Then one would be inside of the other. Because if you do BGH, you're looking at this angle, and we can't have one inside of each other. BGH is this black angle. Not this one, but this.
But where's the original?
The original's red.
Oh.
The originals are red. Yeah, so we started with BGC. The originals are red. We had green adjacent, blue adjacent, and black adjacent. Any other questions?
Why didn't we do questions?
We're not there yet. Okay. Got that captured. CEH. I'm again going to make my start angle red just to keep things easy. So CEH is actually right here, using this edge and this edge. Now that we've talked a little bit, check with your neighbors real quick. Check with your neighbors on what they have listed as adjacent. There are multiple right answers. I crossed it out because I wasn't doing that one there. I said that, Abby. I said I'm only going to do this one on this slide, the next one on the next slide. All right. Mr. Braun, give me one angle adjacent to my red angle there. GEH starts at G, uses vertex E, goes down to H, it lives right here. That is adjacent. Correct. GEH. Or you could have called it HEG, but those are the only two ways to name that. It's GEH or HEG, but there's only two different ways to name that. Casey, you know another? BEC is right here, uses these edges, it shares the side, it shares the vertex. So we could either say BEC or CEB, up to you. Do not cross out D, we're just not doing it yet. Xavier? Yeah, we don't normally use a straight angle like as trying to make pairs. We could say that it is an angle because it has the vertex. So if we were going to use straight angles, what was the straight angle you were going to say? What is it? BEH uses that shared edge, uses the vertex E, so it could be. Likewise, which I think is what Hayden was going to say, this straight angle, CEG, shares this side, shares the vertex, could be an adjacent angle. But we don't normally talk about straight angles with adjacent pairs. Hayden? No, thank you for asking. BEG is right here and uses these edges. It does not share a side with my red. See how my black sides do not share with my red? That's what makes it not adjacent. So those would actually be a special relationship that we call vertical. And we'll get to that, like, I think, maybe tomorrow. No, probably not till next week. Tomorrow is Thursday. Yeah, we'll be starting your inequalities test tomorrow. So, by the way, make sure that homework's done again. Chapter 10 is your lower priority. Chapter 9 is your highest priority to get done. Let me know if you need help, etc., etc. Looking at D, ABC is my start angle. So, ABC, is that the only way that I can draw ABC?
No, it can be C.
We don't normally.
C, B,
Like,
A.
I want you guys to try to avoid thinking like that. We can, we just don't normally. Does ABC have to open to the right? How big is it? 180, right? So, is it still 180? Is it still angle ABC? So if I look at the angle pointing that way, then can I find some adjacents? Give me one. You say GBC? GBC would be right here. Shares the side, shares the vertex. GBC would totally work. Anthony? FBC. FB down to C. This angle would work. Is he? GBA. GBA is this angle. It works. Running out of colors to switch between. Justin? HBG. That one can't actually. So check it out. The arc right here, I don't share a side. That's the issue. I use this side and that side, but I don't have a shared side. Now, you can use HB, but not G. HBC would be this angle right here, so HBC would work. Oh, you're right. I can change to other pen colors. I keep forgetting. Are there more, Abby?
Could you do BGF?
No, because B has to be your vertex. So how you just named B first, B would not be your vertex. How would I get this angle right in here? What's the name of that guy? AB, either D or F. So I could say ABF would be yellow. We did, so here, let's check them out. We did the acute angle, we did the right angle, we did the obtuse angle, then we did the right angle, we looked at why this angle won't work, and then we did the acute angle. We did all of them. Now, I could name them other ways, but there are no more actual angles that we can use. Any questions on how we found those various adjacent angles? Let's try the got it. I want you to list each of the angles adjacent, regardless if it's a single angle or a combined angle. We look at EOD first. EOD. Start us off, guys. Justin, give me one. EOC. You say E or B? E. EOC? So, so that's the
Good
dangerous
morning.
thing.
Ben Eisel, please come to the office. Ben Eisel to the office, please. Thank
So
you.
you're probably thinking this EOC, right?
Yeah.
We try to avoid talking about angles over 180 degrees. We can, but for what we know right now, I'm going to rein you in a little bit and say try to choose acute angles if possible, or try to choose angles under 180 if possible. So is there another EO that we could choose that isn't all the way around? EOB, crap. So if I use EOB, that's right here. It's still over 180, but we can use it if we want. So if this confuses you, because here's why this sometimes confuses people. Give me a second. EOB could also be looked at as this angle, which then doesn't work. But if we look at EOB as the outside angle, it does work. We just normally avoid that. So that's fine. We can leave it there. Don't let it confuse you, though. Xavier? EOA, right here, that'll work. Andrew?
DOB.
What is
DOB.
DOB is right here. That shares a side and a vertex. Yeah, Lily?
I'm not sure, but what about DOC?
DOC is right. I should not use red right there. Is this. So that'll work. And of course, I could switch the lettering and name it COD if I wanted. COB, check it, would be right here. It doesn't share a side with the red. So that's your issue there. Anthony? BOA does not share a side with your red. BOA would be right here. Does not share the side. I believe that unless we combine more and make my angles more complicated, that's about all we could do. Now, if we take the Justin approach and look at every combined angle possible, then we have more. Because then, we could also combine these and go around this way and say DOA, dead on arrival, that direction around. We could do this direction that he tried initially. Like, we can get more, but for our understanding, let's just leave it with what we have there. Any questions before that whole angle combining? Flip to the back real quick. We got a few minutes left. So this is where some people, with depending on how your brain is structured, they just see these and they go really, really fast. They tell us PRS is 80, PRS is this, that combined is 80 degrees. So how would I find the angle that is notated with X, but it's actually QRS? Grace? We know that that blue angle comes from 25 and the other thing, which here is X. So, to solve for just what X is, we need to think about 80 is X and 25. So just like Grace said, get rid of it, subtract it. We end up with an angle degree of 55 degrees. Any questions? Now, really quickly, I'm going to show you some cool relationships. This is not part of the lesson directly. You are totally fine to do your homework tonight. This is just a couple other cool things I want to show you guys. Yeah, but like some of those I like. Like, I don't dislike everything about digits. I actually like a lot of it. Just not the homework side, which you guys resoundingly got me to stop doing. In the figure below, we see that these lines are parallel. So if you want to notate them, and we're not to our geometric drawing yet, but those arrows tell us that the lines are parallel. They keep going the same directions forever. Angle 2 has angles adjacent to it. What would they be? Angle 2, if this is my angle that I start with, angles adjacent have to share a side and share a vertex. Angle 3 shares a side and shares the vertex. And so does Anyone? Angle 1. If we look at angle 5 as my start angle, what's adjacent to angle 5? Angle 6 and 8. Now, where this relationship is headed is actually angle 2 up here would be equal to angle 4. And angle 5 would be equal to angle 7. So we're going to start to see some really cool relationships that happen when we work with parallel lines. But that's all that we need to do today. You guys are ready for your homework. Please let me know if you have questions that I can help out with. Thank you guys very much. Have a wonderful day. Please give me